Hello and welcome to AspireVision, the YouTube channel that inspires you to learn more about science, technology, health, space, and personal growth. In this video, we will explore the fascinating science of graphene, which is a super thin material that has amazing properties. What is graphene? Graphene is a one-atom thick sheet of carbon atoms arranged in a honeycomb-like pattern. It is the thinnest, strongest, and most conductive material ever discovered. Graphene is also transparent, flexible, and biocompatible, making it suitable for a wide range of applications. Graphene is considered a 2D material because it has only two dimensions, length and width. Graphene is also the basic building block of other carbon-based materials, such as graphite, charcoal, carbon nanotubes, and fullerenes. How is graphene made? There are many methods to produce graphene, but the simplest and most common one is called mechanical exfoliation. This method was first used by André Geim and Konstantin Novoselov at the University of Manchester in 2004, who won the Nobel Prize in Physics in 2010 for their groundbreaking work on graphene. Mechanical exfoliation involves using a piece of adhesive tape to peel off thin layers of graphite, which is a form of carbon that consists of many stacked layers of graphene. By repeating this process several times, it is possible to obtain single-layer or few-layer graphene flakes that can be transferred to a substrate, such as a silicon wafer. This method produces high-quality graphene, but it is slow and expensive. Other methods to produce graphene include chemical vapor deposition, CVD, liquid phase exfoliation, LPE, epitaxial growth on silicon carbide, SiC, and reduction of graphite oxide, GO. These methods can produce large-scale or low-cost graphene, but they may have some drawbacks, such as defects, impurities, or poor control over the number of layers. What are the applications of graphene? Graphene has many potential applications in various fields, such as electronics, energy, medicine, composites and coatings, sensors, and more. Here are some examples of how graphene can be used. Electronics. Graphene can be used to make faster and more efficient transistors, semiconductors, displays, memory devices, and circuits. Graphene has a high electrical conductivity and a high carrier mobility, which means that electrons can move faster and more easily through it than through other materials. Graphene also has a high optical transparency and a high mechanical flexibility, which means that it can be used to make transparent and bendable electronics, such as touchscreens, wearable devices, and foldable phones. Energy. Graphene can be used to improve the performance and efficiency of batteries, supercapacitors, solar cells, and fuel cells. Graphene has a high surface area and a high chemical stability, which means that it can store more charge and last longer than other materials. Graphene also has a high thermal conductivity and a low electrical resistance, which means that it can dissipate heat and reduce losses in energy conversion devices. Medicine. Graphene can be used for various biomedical applications such as drug delivery, biosensors, tissue engineering, and implants. Graphene has a high biocompatibility and a low toxicity, which means that it can interact with biological systems without causing harm. Graphene also has a high specific surface area and a high adsorption capacity, which means that it can carry drugs or molecules and release them in a controlled manner. Graphene can also be functionalized with different biomolecules or nanoparticles to enhance its properties or target specific cells or organs. Composites and coatings. Graphene can be used to reinforce or modify other materials, such as plastics, metals, or ceramics. Graphene has a high tensile strength and a high Young's modulus, which means that it can make other materials stronger or stiffer without adding much weight. Graphene also has a high corrosion resistance and a low friction coefficient, which means that it can protect other materials from wear and tear or environmental damage. Sensors. Graphene can be used to make sensitive and accurate sensors for various physical or chemical parameters, such as pressure, temperature, humidity, gas, or biomarkers. Graphene has a high sensitivity and a fast response time, which means that it can detect small changes in its environment and react quickly. Graphene also has a tunable band gap and a large surface-to-volume ratio, which means that it can be tailored to different sensing applications or integrated with other nanomaterials. These are just some of the possible applications of graphene. There are many more areas where graphene research is making an impact or exploring new possibilities. Graphene is truly a remarkable material that could revolutionize many industries and improve our lives. Conclusion. In this video, we have learned what graphene is, how it is made, and what applications it has in various fields. We have seen that graphene is a 2D material with extraordinary properties that make it ideal for many applications. Graphene is a disruptive technology that could open up new markets and even replace existing technologies or materials. Graphene is still a young and evolving field of research, and there are many challenges and opportunities ahead. We hope that you have enjoyed this video and learned something new about graphene. If you want to learn more about graphene or other topics related to science, technology, health, space, and personal growth, please subscribe to our channel AspireVision and hit the bell icon to get notified of our latest videos. Thank you for watching and see you in the next video.